All right, so here's today's bell ringer. It basically says your science teacher asks you to make a model of a solar eclipse. After some research, you decide to use this illustration to form your model. It will be a three-dimensional model of the drawing. So basically, you chose this model, and then you would have to come up with a three-dimensional version. However, your teacher comments that your model is going to be inaccurate. So which one of these statements best explains why it would be inaccurate? So I'm going to see what you guys have come up with. Okay. And the correct answer is, in fact, B. The comparative sizes of the objects are inaccurate. So B is the best response. And that is because if you look at the model, clearly the model makes it look like the sun and the earth are about the same size. But I'm sure, as you know, after sixth grade science, that is not the case. The sun is much, 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 much larger. And if you're asked to create a three-dimensional model, anything that is used in the model should be drawn to scale, meaning the relative sizes are accurate in terms of their differences. Okay. And some of the other options didn't really make sense. So A, for example, says there's no way to include labels. It doesn't really make sense. For C, the incorrect components of a solar eclipse are included. Well, all you need for an eclipse is, well, the earth, the moon, and the sun. So all of those three components are there. And then lastly, it says there's no way to cast a shadow to represent the eclipse, which is not true, because let's say you use this model, you could always, use a flashlight or something like that to represent the sun. So the correct answer here is B. All right, so I'm going to answer a couple of questions on the graph. So here's our bell ringer. Let me go back in and pull up the model of the graphing assignment and show you guys what it should look like. And after that, I'll go over your lab activity you have today. So give me just a minute to transition to that, and I'll answer questions. Okay, so right now I'm sharing my screen with you guys. Give me just a second to kind of shuffle things around. Okay, so here we are. This is my version of what you guys also have in terms of that graphing assignment. Everyone should already have the data. I went over the data. I told you guys what the correct responses were to make sure you had the right information. If you were not here for that, or you didn't do it, or whatever the case may be, please go back and watch the recorded lessons that I've posted. That way you can have it. Okay, so I'm not going to go back over those data points today with you because I've already done that. So if you need to go back to that point and find that information, you can go back and find that in a pre-recorded lesson. So the examples I'm going to go over now is, again, explaining how you're going to graph this data. So for part one, this graph corresponds to part one. In part one, you were graphing the relationship between mass in kilograms and energy in joules. In your data sheet right here, it says helpful hints. Use increments of 25 joules for energy and increments of 0.05 kilograms for mass. Increments are what you assign to each of these little lines. Okay, so everybody sees all these lines represents an increment. So for mass, this told you to use 0.05. So what I did was I created a text box and I typed in these values, and then I basically put it on the chart to align with each of these intersecting points. Okay, so that one is 0, this one is 0.5, then 0.10, 0.15, 0.2, 0.25, 0.3, all the way across, going up by 0.5, excuse me, 0.05, until all of these lines are marked. Okay, it's pretty easy. All you're doing is just slightly shifting. Okay, and if it shifts too much or it moves over too much, you can always adjust it. Right, so you can stretch the text box out like this. There you go. And then again, you can adjust it. See, so that's my units of measurement for mass. Now energy, to do this side, I basically copied this text box and moved it over here. You can rotate these text boxes, see? So if you want to move it over here, you got to be careful because sometimes the back picture will move, but that's fine. You can just align it back again. If you go to this text box and click on it, this is where you're going to put in the units for energy. Okay, all of the information that I'm typing in here is going to come from your data sheet, which is part 1, and that was the one that you guys should already have finished. So this is going to be the units that we are going to use for energy. It tells you right here, helpful hints, use increments of 25. So the bottom corner is always going to be 0, and then each line going up. So that'd be 25, 50, 75. 100, 125, so on. And you would do that all the way up to 375. Once you have that, I showed you guys you can rotate it. See how this shows up? You can kind of rotate it. Once you have it all keyed in, you can just kind of spin it around till it looks good. And then you just move it over here. And then you can align it. Okay. So for example, that looks pretty close. And if you're not sure or you need to shuffle them around, well, you can do that. You can just click on the text box and move it just like we did in the other example. So you can kind of just move everything around. I do recommend that you shift one before the ones at the bottom first. The 25 looks pretty good, but let's say you want to move the 50 up. 75 looks good. There's 100, maybe move 125 slightly. So all you're doing is kind of getting these things to align. And you can always change the font. You can make it smaller if you need to, but otherwise this looks pretty good. And you can just click outside to check. Okay, so most of the axes are labeled now. The next step is to put your data points on the chart. So what I suggested that you guys do is just use some shapes, okay? So here's a shape right here, and you can kind of adjust the size, and you will have 10 of these total. And what you're going to be graphing is you're graphing the points where these things intersect. So we're looking at part 1. Again, you guys have this data in a Google Doc. So you should be able to access this. So let me pull that up just in case some of you are still not getting it or not following along or whatever the case may be. I'm going to pull that up and show you. And again, I went over this, so if you guys need to go back, you can do that. All right, so here's my little version. Okay, so this is part 1. This is the data we're going to graph. So the graph is going to show us the relationship between mass and joules of energy. So we need to put a point on our chart that we're creating, our graph that we're creating, where mass of 0.046 aligns with a unit of 26 joules. So these intersections between the mass and the kinetic energy for each of these sports balls are the points you're going to put on the graph. There are 10 total, so you should have 10 total data points on your graph. So let me go back to that now. So now that I've done that, the first data point was 0.046 for the mass. Okay. And 26 joules. So again, this is just kind of an estimate. These charts aren't going to be perfect, even for in-class students who had a physical copy where they were using their pencil to graph. It's not going to be perfect, but you should see a generalized example, excuse me, of how this data will look. So after you've made a shape, what I would do is I would make it a little smaller, right? So they only need to be about that big. And then what you can do, just to make it simple, you can make a copy of it. So you have the same size once it's set up, and you're going to need 10 of them total. But make sure you're actually on this little point here. So I'd say copy, and then you can just paste it on there. Okay. Just kind of keep going until you have 10. So that's kind of my example. Now, once you have all these shapes, you're basically going to put them on the chart. So the first data point is 0.046 for mass, so that's going to be somewhere about right here, and 25 for the joules. So you're going to take a data point. Come on, you. My mouse is sticking today, you guys. And you'll put it here. Okay. See, there's your data point. Then you'll get the next one for the tennis ball, which was 0.057. We can round that up to about 0.6. And that's going to correspond with 32 joules. So again, we're going to scoop that up. And it's not going to be perfect, but it'll be somewhere about right in here. Somewhere in that generalized area. And then we're just going to keep going. The next data point for the baseball was 0.142 and 80 joules. So again, somewhere near 70. 0.14 somewhere over on the other side of 0.15. This line corresponds to 75, so a little bit above that. Okay, right there. And let's see, the next one was lacrosse. A mass of 0.15 and kinetic energy of 84. Grab you another data point. 0.15, 84, so they're going to be really close, so about right here. See, there's a little bit of overlap where they touch. That's okay, because at the end of the day, you should still observe the same pattern that you would observe if you graphed it by hand. So we now have the golf ball, the tennis ball, the baseball, the lacrosse ball. The next one is field hockey, which has a mass of 0.156 and a kinetic energy of 88. So we can round up 0.156 to about 0.16 or even close to 0.2. And that corresponds again to a kinetic energy of 88. So grab that guy. So close to 0.2, kinetic energy of 80. So we're going to squeeze this about right here. Okay. So they're all going to be really close to each other. What you should observe is that some of these things kind of cluster. And if you get them on here and you feel like you need to move them, all you have to do is click on them and then you can kind of move it down a little bit or over slightly and so on. So your job is to basically continue to graph these points. And what you will observe is that you will see a steady increase, because by now you guys should know that as mass increases, what also increases? As mass increases, you should also see an increase in kinetic energy. And I'll just put a couple more points on here. So let's put the biggest one. The basketball, for example, has a mass of 0.6 kilograms and 350 joules. So we'll take the biggest one, which means the data point will be way up here because the mass is 0.624 and 375. So that data point is going to be way up there. The soccer ball was a mass of 0.4, kinetic energy of 241. So let's see what that one looks like. So kinetic energy of around 350, 0.14 versus 0.4. Somewhere about right there. Okay, so what I've done is just graphed a couple of these points to show you an example, but you should see somewhat of a straight line. It's not going to be perfect, but you should see that these data points kind of follow this pattern, that as you increase in mass, you also have an increase in energy. Okay, now, does that help some of you guys who had questions? So those of you that are kind of following along and listening, does this help clarify how you can? Okay, good. All right. So you're going to do the same thing for part 2. So remember that. So this was part 1, mass versus energy. In part 2, it was speed versus energy. So all you do for part 2, you're going to set it up the same way. And you could even, if you really wanted, you could just, you know, copy one of these text boxes and you should be able to move it to the next slide. Copy, go to the next slide. There you go. Now, once you have them made, you can copy and paste it. And then all you have to do for speed versus energy, right? This comes from part 2, speed versus energy. So for this one, this is your speed. Remember, speed changes. So your velocity is 7, 11, 16, 20, etc., all the way down. And then these were your kinetic energy measurements. So you're again following the same pattern. So all you would have to do once you've copied and pasted it on here is go in and change your values, adjust them. And then you will plot your points on the chart just like you did in the first example. All right, so now that I've gone over that, I'll give you guys until this evening to submit that so you can work on that today. So any more questions on how to do this before I transition back to what I have for you guys to do today? Any other questions on how to create this graph? Okay, so I'm going to change my sharing settings. Okay, so a lot of people are asking where this is. This was assigned earlier in the week. So I'll show you guys where these documents are. So let me change my settings and go into Schoology so I can show you. So let me go to 4th period, 3rd quarter. This assignment was originally assigned earlier this week. Here it is. So everybody asking questions, this is where you find it. Virtual students calculating and graphing kinetic energy. This is part 1. This is the part that goes along with the Google Doc where you should have typed everything in and have all those data calculations. If you don't have that done and you don't know how to do it, please go back and watch the lesson that I've already recorded and posted on the pre-recorded lessons YouTube channel. It's up there. The second one here, part 2, this is where you find the graphing portion, okay? So it'll say, it'll be a Google slide, Littlepage, graphing, kinetic energy sports. So all of these documents, these 2 assignments are found in Monday, March 1st folder. Okay, so again, Monday, March 1st folder. Any other questions? All right, so for today, as you guys have probably followed the pattern so far, I typically have some type of lab for you guys to do on a Friday. So this is kind of the virtual version that I'm having in-class students do. So we're going to be doing a lab that observes the relationship between kinetic and potential energy. So there's 2 things here. There is a Google Docs that is labeled as kinetic energy sheet. That goes along with the link here. So all you have to do is click on this and it's going to tell you what to do. Everything you need is listed here. This is a pretty simple lab. And that's, again, it's very similar to what we're doing in class today. So what you're going to do is you're going to work through each of these steps. So for this one, it shows the relationship between potential energy and kinetic energy and how that can change based on mass and, of course, friction. So when you open the document, here's a link, and then you're going to follow what it tells you to do. So for example, one of the first things it says to do is what happens when you make friction and gravity 0? Well, you do that and answer the question. Second section here, put friction and gravity to the middle. Now change the skater's mass. What happens as you increase the mass? So similar to what we've done in the past, you're going to follow the steps and manipulate the lab. So I'm going to show you what that looks like real quick before we break. So when you open it up, it's the PhET lab, interactive simulation. You're going to click on this first one right here where it says intro. And here's our skate park. So there's a couple of things you can click. One, you can change your person. If you want to have a dog, you know, a guy, a girl, different skin tones, whatever character you want to choose, it's up to you. But all of them, you can see you can manipulate their mass, and then you can manipulate friction and gravity. So I'll use the dog, okay? And one of the first things it says is to turn everything down, gravity and friction. You can also click on the pie chart. This is a great one to see because it tells you kinetic versus potential energy. You can expand a graph here. Look at the speed and the path. So once you've done that, pick your little dog or person up and let it go. And you can kind of see the change in kinetic versus potential energy. And this is, of course, with no friction and a very small amount of gravity. So what do you expect to happen since friction is put at none? What do you guys think? Is this guy going to stop or is he going to keep going? If friction is set to 0, he's going to keep going pretty much, okay? Now let's see what happens if I turn up gravity. Okay, so this is kind of a good example to show the relationship. So this poor dog on a skateboard is experiencing 0 friction and really high gravity. So obviously when I did this, it changed his speed quite a bit. And you can see the relationship between kinetic and potential energy. Now that I've done that, let me see what happens when I change this thermal energy setting. So let's put lots of friction on here. And he slowly stops. All right. So this is just kind of an interesting lab that you guys can manipulate. So after you play around with it for a little bit, go back to your Google Docs here. Make sure you go through each of these. It's a pretty short lab activity. So these correspond to the first scenario here. These are the second ones. All right. So you should be able to do some measuring here as well. So let me go back and show you what that's going to look like. So this was the first one, the intro tab, right here. Does everybody see that? And what that means is we clicked on the first thing. So does everybody see down here at the bottom, you can change? So the first portion was the intro tab. We've done that one. When you go back to the second part, it says click on the measure tab. So then you go back in down here, you'll click on the measure tab. And then you're going to follow the instructions for this one as well. So put the skater on the track and use the measuring tool to measure kinetic and gravitational potential energy. So put this person on here. All right, and so you can basically measure that. So you see how you can move that up here? So let's restart. Put this here. Then you can let her go. Oh no, I didn't put her up there all the way. So you can basically record what's happening, right? So you see where you can put it on each of these data points and it will tell you what she's experiencing. So at this point, when she passes by, right, you got to get it on the data point, it'll tell you. Okay, so you can kind of measure it. And you can turn each of these things on if you want, so you can see more information. All right, so after that, your last portion is the playground. And at this one, which should be the most interesting, you're going to create your own track. And so this is the third one right here. And then for this one, you can kind of manipulate things. You can build them. You can make them really high. You can put another one up here. So you can just kind of change it up if you want. And there she goes. All right. So that's it for today. Let me change my settings. So any questions on this lab activity that you guys are going to be doing? All your instructions are here. Once you finish that, you can submit. It should not take you guys the entire class period to do that. So I'm going to stop sharing for just a minute. And I'm going to come back to my camera. All right. Ooh, I see my hair. Excuse me, guys. Got a little messy hair here. So, all right. If you guys don't have any questions, you're good to go. Make sure you turn in your graphing assignment. If you need to go back and look at that data, I have that posted. You also, I went over how to do your lab, so you can submit that. And any makeup work you need to do, make sure you get it done. All right. Otherwise, you guys are good to go. You can leave the WebEx, work on your lab. Have a great day. And I'll see you on Monday. Okay. Have a great weekend, everyone. Bye. Bye, everybody.